So Jacob is solving the equation by using successive approximations. So his equation is 2 raised to the x minus 4 is equal to 3 raised to the negative x minus 2. He started from the graph where he found the solution is between 1 and 2. Using the lower and upper bounds from the graph, Jacob did the following work for the first iteration. So he set his upper bound to 1 and evaluated at 1. Oh, no, I'm sorry. Step 1, he set the equations equal to each other, then solve for 0. Then he evaluated it on step 2. He evaluated the equation at 1. In other words, he plugged in x equals 1, and then he evaluated it at the upper boundary of 2. And so he had a negative value and a positive value. The positive value indicates that your upper boundary is too high. Okay, so this means that he has to change the upper boundary. So what he's going to do is take the average between 1 and 2, right? So here's the upper boundary of 2, here's the lower boundary. Well, we can think of it in terms of the graph. Here's the I gotta reverse the order so you guys can see it the way that you're thinking. So you have the lower boundary of 1. I don't know if the camera reverses it. We'll do it this way. So you have 1 and you have 2. Because 1 is negative, it's too small, but that's okay. But 2 is positive, so it's too big. So what we want to do is just keep lowering things, okay? So he's at 2. Well, what's right between 1 and 2? 3 halves. So if you add 1 plus 2 and you divide it by 2, you take the average. So now you're going to change the upper boundary and lower it a little bit. Okay? So if you lower it a little bit, then that's going to give you a new number to plug in. So by lowering the upper boundary a little bit, he evaluates it at that number, which is, so we're 1 and 2, then we lower it to 1 and 1.5. When he evaluates it at 1.5 in step 4, he gets 0.636. So 1 and 1.5, 1.5 is still too big because it's positive. So now we're going to try to find something in between 1 and 1.5, which would be 1.25, right? But 1.25 is actually going to be, you would replace 1 plus the 3 halves, okay? So that's where we're at. So then step 5 says, since the value is positive, replace the previous lower bound so that the boundary is between 3 halves and 2, okay? So, oh, wait, I said that backwards earlier when I was describing it. So what we're going to do is we're going to now find the average between, because they're both positive. Oh, no, wait, I said it right. The statement, step 5, is saying because it's positive, he should replace the lower bound. So, okay, I get it now. So the question said, where did Jacob make his mistake? Well, it's in step 5, because if it's still positive, that means that this number's too big. So we would have to lower it a little bit. We would lower it until it's negative, and then we would know, right? So what we're doing is we're just we know that this is too little, but eventually we'll get closer and closer and closer and closer. And when it finally becomes negative, we know the one above it is a good approximation. And what we're doing is we're halving it. We're taking half, we're just slowly getting closer and closer to where it equals 0. So anyways, what we're going to do then, I think it's C. Because C says Jacob made a mistake in step 5. He should have used x equals 3 halves as the new upper bound, right? We should have replaced 2 with 3 halves. He replaced the lower bound. We shouldn't have done that, okay? So anyway, C is the correct answer.